Good morning, everyone. Good morning. You can hear me, right? Okay. Um, I think I'd be remiss if I didn't take a minute to just say thank you to the team here at UW-Madison for putting on this great conference. So let's give them a hand. This has been a great learning opportunity for me, and one of the things that I've picked up here is that you all have very deep expertise in different things that I don't have much knowledge of. So I've learned a lot here. What I'm hoping to do is to help you understand how you might think about using public cloud services and AWS specifically to process and distribute imagery that you're bringing in, right, or that you are aware of use cases for. So a few things. Well, first of all, I'm a specialist solutions architect at AWS. I'm part of the aerospace and satellite team, which is actually quite a large team. We just launched it about a year ago, a year and a half now. And primarily what we do on the aerospace and satellite team is we have a team of account managers and solutions architects who support customers and people who are just getting started with AWS with using our aerospace and satellite oriented services. And that includes customers like launch vehicle providers, or launch providers, launch vehicle builders, satellite builders, many other kinds of, and the traditional aerospace and satellite things. And that's across all different vertical markets, public sector, private sector, government, etc. So I specialize in the AWS Ground Station service. AWS Ground Station is a fully managed service that allows customers to connect with their satellites, uplink and downlink, so command and control plus payload in S-band and X-band today. It's S-band up and down and X-band downlink. We're in 10 global regions today, and I'm going to talk a little more about this, but I wanted to just share some highlights so you have some context. And basically the idea behind the ground station service is to give you a way to contact your satellites without or satellites that are direct broadcast without having to build your own ground station infrastructure, and or to augment existing ground station infrastructure so you can get better coverage, or you can have the ability to deal with failures in other systems, etc., just by creating more coverage. So there's a lot of opportunity there. Here's what we're going to cover. First of all, I'm going to talk about why we chose to use CSPP for event-driven architectures, and talk a little bit more about ground station, what we built and why in terms of this particular architecture. And then I'm going to do a deep dive in how we architected and deployed CSPP on AWS for this event-driven architecture. There's some opportunities for improvement, if you will, of both the architecture as a whole, and also I see a lot of opportunity to collaborate on improving these architectures. One of my roles is to create reference architectures and design patterns that we can share with customers, and I hope to collaborate with a lot of you to do that going forward, because there's a whole lot that I don't about how these workloads actually work and what people need out of them. Also going to talk about how you can try this, and provide some information about AWS for space at the end. My tendency is to dive deep really fast, so I'm going to be watching for glazed eyes in the room, but I also hope we'll have a lot of opportunity to interact after the session. So why did we choose CSPP? Well, specifically, when I say event-driven, first of all, I should talk about what that means. So an event-driven architecture in AWS terms means that you take an action based on something else happening. And that can be as simple as an object, a file, arriving in a storage container, right? And you trigger some process based on that. Or it could be the completion of another process that triggers the launch of another process. And event-driven, of course, is a big deal in this kind of space, because you have these very well-defined periods where you have a satellite contact or pass where you ingest data, and as soon as that's done, you want to be able to do something with it, right? You don't want to have to, and you want to be able to do that in an automated fashion. So that's what I mean by event-driven in context. So what we chose to do to demonstrate this capability is we use CSPP, specifically Veers SDR and Polar to Grid, and we package them, we containerize them. So what that means is that they're running in a container inside of another compute environment, and it's a Docker container specifically. CSPP is much faster than IPOP. Thank you to the CSPP folks for that, and in the same compute environment. And we're going to talk more about specifically what that compute environment looks like here. It works well with AWS services such as Amazon EC2, which is, you might hear of or have heard of EC2 instances. An EC2 instance is an Amazon EC2 virtual machine. EC2 is Elastic Compute Cloud. It's just a virtual machine. So when we talk about EC2 instances, that's what we're talking about, is virtual machine in AWS. EBS is our Elastic Block Store service. So that's an attached disk, attached to an EC2 instance, typically. And CloudWatch Logs, that's our log and event service that basically you can use to monitor lots of different kinds of metrics, including things like application logs and operating system logs, but also services. So for example, the ground station service generates CloudWatch events when when we go into pre-pass on a satellite, right? So it gives you time to start an instance to get it running, for example, and also when the pass is over. It's open source code, and of course, because containers are cool, we have scalability, performance, and cost optimization advantages with containers. So a little bit more on ground station. As we talked about, it's a fully managed service. And we do have if you go to the AWS ground station site, you'll see one of the things we have on there is a map that shows the 10 regions globally where we're located today. AWS ground station is, this is one of our actual antennas. We have more than one antenna per site at each of these 10 regions. And fundamentally, it's an aperture and a digitizer, and of course the other pieces that are required to do things like tracking and so on. These antennas are, we own them. They're connected by AWS-controlled private fiber connections, high bandwidth, low latency, very often on the same physical property as our data centers are. So that means that we have the advantage of being able to bring data in from the ground station service and deliver it into a region where you can process it very fast compared to having to backhaul it somewhere else to process it. And also it gives you the advantage of being able to centrally process data from many global regions. So we have a feature of ground station called cross-region data delivery, where you can stand up your compute resources in one place. Let's say it's in Ohio, for example, in one of our regions. And you can schedule contacts at all of the global regions and backhaul that data to that Ohio region for processing. And we don't charge you for that data transfer. So that's cross-region data delivery as part of the service. And also for customers who have their own satellites where they have to, of course we have licensing and regulatory requirements with every satellite, right? So we pay for the licensing charges on the AWS side. And that's another part of the service that's worth mentioning. This is a little bit of what the architecture looks like. It starts out with onboarding, which is something that I work directly with customers all the time to do. And of course you can do command and control and downlink. So you have TT&C functionality, payload data, and then process and distribution, as we just talked about. So this is what we built for this event-driven architecture. We're using JPSS1, and we're processing at level 0 output, which I'll show you in the architecture diagram in a minute. And it processes data that's triggered by the arrival of a new L0 product. So as we talked about before, one of the things that we can do is when an object arrives in a storage container, what we call an S3 bucket, in this case simple storage service is what S3 stands for, that triggers this workflow, and you'll see the rest of that in a moment. The output of that process triggers an Amazon machine learning service that creates a cloud overlay. So it's really interesting that I'm following this session where we're just talking about creating these cloud visualizations. And this one is pretty crude by comparison, but it gives you, basically it's about the art of the possible, right? Which is how you could use these services to apply them to these types of workloads. The architecture is the basis for a workshop, which I'll talk more about later as well. One thing to keep in mind about the workshop is that we deliver that workshop we can do that in person for many people. And we use a platform called Event Engine to host those events. We have some constraints in Event Engine around the size of compute and the fact that we can't use GPU instances and things like that. That scope down somewhat what we did for this workshop in this particular architecture. So what I'm saying is that the architecture as a pattern is applicable to more than what you see here. And from a scalability point of view, it could scale much larger to much higher performance than what I'm going to show you, which is just a single container. So let's talk about it a little more in depth. So our design choices for deployment. We built on Amazon EC2 as a compute instance, running CentOS and Docker. We have multiple ways of hosting containers. One of them is called, of course you can host containers on EC2 just like you can on a physical or virtual machine on your laptop or on premises on a server. And so we chose to use EC2 to host a Docker container. And we chose that over our Fargate service, which is part of our container, our ECS, Elastic Container Service, and EKS, Elastic Kubernetes Service, because we wanted to use 8 physical CPU cores to process the data. And that lets us complete the processing more quickly in about a 20-minute period. There's 5 tarballs installed on the container. One of the challenges we have with that container is attaching a disk to it to provide the lookup tables. We'll talk about that in a second. Good thing is lookup tables and tiles compress really well, but that creates some other challenges that we'll talk about in a minute. The ancillaries, the spacecraft parameters, orbital information, software downloads those on the fly. The lookup tables, though, are more than 100 gigs after decompression. So that's another thing that limits our, how we would deploy this in this workshop setting. But in production, you have other storage choices. So rather than install these on the container, because that would actually cause the container to really bloat and also to make the deployment take longer, what we did is we put them on an external volume, and then we created a snapshot. So that external volume is an EBS volume, an Elastic Block Store volume. We create a snapshot from that, and then we can spawn additional volumes from that snapshot on the fly. And it just takes a few seconds to do that. So yeah, we put the lookup tables on an EBS snapshot. The batch job, as you'll see, when it creates an EBS volume to attach to the container at launch time and mounts it at a specified mount point. Functionally, that's how we decided to deploy for this. This is kind of the most basic way of doing it, and there are other ways that we'll talk about in a minute. So we wind up with a stripped down container with just the application binaries. We have more optimal storage options, including Amazon Elastic File System, or EFS, which is an NFS service that allows multiple containers or instances to mount that file system simultaneously. And that has a lot of advantages. It would allow for scalability, for example. As you add more containers, they can all mount that same file system, and that happens very quickly, as opposed to creating an EBS volume and then attaching it to each one of them, which both wastes storage and costs more because you have to pay for those volumes individually, right, as opposed to one file system that is mounted by multiple containers. Also, it would allow the lookup tables to be updated at any time rather than updating a volume and taking a new snapshot, as is done with the EBS snapshot method. More optimal cost-wise would be to use Amazon S3 for things like lookup tables. Anything that's object-oriented or file-oriented is a great use case for S3 because it's less expensive. It's very highly durable. It has 11 nines of durability. But the software would have to support the S3 API. So this is the data flow of the event-driven architecture that we're going to talk about. On the left side here, what that left-hand column is in one AWS account. It's a centralized account where we have the JPSS-1 satellite onboarded. And then we use the AWS ground station service to downlink an image from, or a contact, if you will, from JPSS-1. And then ground station emits what's called a pre-pass event, which triggers an Amazon Event Bridge event, and that launches an EC2 instance that's running NASA RTSCPS to produce the level 0 output, and then it drops that into an S3 bucket. I learned this week that we have alternatives to RTSCPS, which might give us much better performance. Thank you, Bruce. So we're going to be exercising that over the next period of time. So once the sensor data records process, we put that, there's a put event rule that gets matched in that Amazon S3 bucket, and that triggers Amazon Event Bridge to create the batch job that you see next in the second column. And what that does is actually spawns that container, and that container is that EC2 instance we talked about with Docker and with the installation of the binaries, the creation of the EBS volume and attachment of that to that container, and then the processing with Veer's SDR. And incidentally, the size of that container is, we chose, this particular instance has 8 physical CPUs, 36 vCPUs, and 72 gigs of memory. It costs about $1.50 per hour to run that container, but it's only running for a few minutes. So, and it's per second billing with a 1 minute minimum. So, this gives you an idea of why event-driven is beneficial, because you don't pay for things when they're not running, right? So an EC2 instance, it's spawned, it kicks off, it runs a job, and then you terminate it, and you only pay for that period of time. Let's say it's running for 20 minutes. That's what you pay for. So that certainly, in my mind, beats buying big iron and having to rack it and power it and cool it 24/7 for the life of the box. But I digress. So at the end, what we do is we drop that image, that geotiff, into S3, and then there's another rule match which kicks off the machine learning inference piece. And you'll see, I don't want to get too deep into that, but what we're doing there basically is using AWS step functions to drive some AWS Lambda functions and a SageMaker machine learning model to take that visual image and use that to produce a cloud overlay, which you'll see in a slide here in just a minute. And then finally, and this is something I've talked with a number of you about sort of in hallway conversations and such, we deliver that finished product into S3 where you could make that available to whatever user base you want. And it doesn't have to be S3, you can deliver it through other means as well, right? But you can put a web front end in front of it if you want to. You can make these objects directly downloadable for your customers, your users, whatever. And you can also, you can provision that through lots of different methods for web-based access, for private access over a VPN connection, or either client VPN or site-to-site VPN, or over a private direct connect circuit. So as you can see, a lot of these things have sort of fan-out options that are way beyond the scope of what's going on in the workshop, but I want you to know what's possible. So, and we can talk more about those things too. So, it's really about understanding what your delivery needs are and then working with you to architect for that. That's part of my job. This is the logical view and of the same architecture we just looked at. On the left side, again, you can see we're producing that level 0 product. We actually deliver it into that S3 bucket in the middle. It then gets processed through that batch job and then delivered back into the output delivers back into just a different folder in the same bucket. Okay. And then that triggers the step functions workflow that does the machine learning inference. And the output of that also goes back into that same S3 bucket, into a different folder. So logically, it could be, and the way you deploy this is really up to your needs, right? But you can put these products into different S3 buckets. They can be in different AWS accounts, or they can all be in the same bucket in different folders. It really depends on what your needs are and how much isolation of that data that you want. Okay. So this is what the output looks like. I created I actually scheduled the pass using a ground station service. I think this one was in Dublin, and you can see, the true color, the GeoTIFF image on the left, and then the cloud overlay that SageMaker produces on the right. There's certainly room for improvement, but it gives you an idea, again, of what's possible in an event-driven workflow. I think we've talked about the opportunities here, except that I'll touch on the second one for a minute. Batch job runs against each container. To make that scalable, the batch job could be created for each granule, and then each granule could be processed per container. And how parallel they would run would be based on the size of the cluster. We would need to also understand some things like whether there is a post-processing gather process that would constrain the architecture. And it would also help us to understand, and this is how I hope to collaborate with you, what Veer's SDR is actually doing under the hood. So we can understand better how we can optimize the architecture for that. How you can try it. How am I doing for time? Okay. So if you would like, I encourage you to use your phone and grab this QR code. It'll take you to a link. The workshop is a published link. It's publicly available, so you can read through. You'll see a lot of screenshots and step-by-step instructions for how to actually deploy and use this in an AWS account. And if you would like, I would be happy to work with you to coordinate the scheduling of a workshop for your team. We've talked about doing that here maybe in the fall. So that's something that we can do for any reasonably sized group. Happy to talk to you about your needs. If you have a team that would benefit from understanding how to use AWS in this kind of an architecture, and ask about any additional things you'd like to talk about. My email address is here. You'll see it on the last slide as well. So, additional ways that you can explore AWS Ground Station. Hands-on experience is always the best, right? For getting started, we have 2 blog posts there, the top 2 links. One is based on Aqua and talks about how to use AWS as a pipeline using AWS Ground Station to process Aqua imagery. The second one, and that delivers to a running compute instance. The second one talks about how to use AWS Ground Station with JPSS1 to deliver imagery to an S3 bucket, and you recognize that that's part of this workshop as well. We also have another link there for our wideband DigIF and actually narrowband and wideband DigIF functionality within the Ground Station service, and then there's a contact link as well. Also, I've talked to a number of you about wanting to get more conversant in general with AWS services and how to use it. So we have over 500 free courses and learning plans that you can build in 16 languages. Take a look at that through the training link at the bottom. And AWS certifications, which gives you prescriptive guidance about how to get prepared for our associate and professional certifications, and also our specialty certifications. These things together should help you, see where you would need to focus to build that competency. And if you have any questions about any of this, please reach out to me. Again, my contact information. So with that, I'd like to say thank you and open it up for questions.
Thank you, Russ. Oh, we have a few.
Thank you. So first question is, you mentioned about JPSS1 time link. My question is, using your existing Amazon Ground Stations, you can locate globally. Is that correct?
Sorry, you can do what globally?
He's asking if you have any gaps in your antenna coverage.
Oh, sure we do. Yeah, of course.
Okay.
Yes, we do have gaps in our coverage.
Okay.
So
if you want to have no gaps, any significant development that you need to do you know an optimal number that you could deploy to increase like within?
Yeah, great question. So I'm glad you brought that up because it reminds me to mention that 90 to 95% of all AWS services and features are driven by customer request. So along those lines, 3 years ago when we launched the ground station service, we had 2 regions. Today we have 10, and we're building more constantly. So there will be several more released over the next year. And what we prioritize based on is customer demand, what people tell us they need. And a lot of that has to do with orbits of satellites that they plan to launch and that sort of thing.
And then did you mention about you have S-band, X-band, S and X-band downlink service?
Correct.
So when the decentralized is using L-band downlinks, they can use the services?
That's correct. We don't have L-band. And there's, of course, the other bands that people also ask us for.
My third question is your command control uplink centralized service. Is that with a separate cost?
No, so that's a great question. The way that AWS Ground Station, the cost model, which is on the pricing page, and I can share that with you all later, it's based on per minute usage. So if you have a 6-minute pass and you want to use that full pass, you're billed on a per minute basis for the ground station service. So uplink and downlink, we don't differentiate between them cost-wise.
Okay. The uplink using S-band is still by minutes.
Yes,
usage.
correct.
Thank you.
Russ, thank you for the presentation. It's very interesting stuff. First is I would like to put in a request as a potential customer for an Antarctica Amazon ground station region. So
Okay, I'll add you to that list.
file that away.
Yeah.
The second thing was in your charts where you showed where RTS TPS, your sort of CAD-UD photo is that running after the pass is finished, or is it running while the pass is in progress?
So it could be either. We have the ability. So that's a great question. A ground station service can deliver to a network interface that's attached to a running compute instance or a running container, for example. So you can process in real time, and a lot of our customers do that. Or we can deliver to an S3 bucket, and essentially what we're doing there is delivering 30-second chunks. They're PCAP files, right, in 30-second chunks. So you could pull them and process them as they come in, or you can wait till the contact ends, at which time we emit an event that you can then use to trigger the launch and processing of data that has been delivered to that bucket. So
my third question is probably a bit broader, and I'm just wondering if in your brief time here in Madison this week, if you could give us an example of, is from your perspective, is an immediate win that I could see for someone in this group, a use case that would just benefit tremendously from either using your ground station service or using your cloud services?
I've observed some, but I don't think I've gotten to the level of depth with any of you yet to understand where we could really be most beneficial. But I would invite you to follow up with me after this week so we can schedule some time to talk one-on-one about your use cases. I do think one thing that I have noticed anecdotally here is that it seems like everyone who uses the word cloud, with the exception of people talking about physical water vapor in the atmosphere, seem to be talking about different things, right? So when we talk about cloud, it means something different to me than I think it means to a lot of others, and I think mutually there's a lot of different definitions of that. One thing that I think would be really helpful is to have some conversations about what people mean about the cloud, right? When they talk about delivering or providing cloud-based services for their customers. So getting us all, like anything else here, getting us all talking from the same, singing from the same pages, right, so to speak, really helps us to be able to collaborate better. and I hope to work with more of you. But I guess I would turn that around and ask, and you don't have to answer now, but what have you seen that this maybe helps you tie together as a use case? And so Marie has something.
So thank you very much. I really appreciate the architecture picture to see how it all fits together. But the event-driven,
Yes.
so kind of reside. How does that architecture even change when you go backwards through that, as in the event, a user request comes in reverse, wanting to maybe access the product or generate it on the fly kind of thing?
Yeah. So, do we have another minute?
Sure, go ahead.
Okay. Okay, we do. So over here on the right is where the user access comes in. That's one piece of that. So I'm assuming that you're in this architecture that you're some kind of a provider, right? You're providing products for people to consume, and so there's two places though where that might actually where that interaction might happen. One is when those users are connecting to either a web portal or whatever, could be as simple as an FTP directory to pull data. And then the other place is over here on the left side where people are actually scheduling contacts. So scheduling contacts through the ground station service can be done through the API, and it can also be done through the web interface that we provide for the ground station service. And of course that requires access to the AWS account where that particular satellite is onboarded. We do have customers who are providing that sort of scheduling as a service through their own front end, and then they interact with AWS Ground Station through our APIs. So that's another place where, for example, if you wanted to provide the ability for a customer to request data from a particular pass that hasn't happened yet, then you could provide that access through the scheduling interface. Of course, there's a lot of other foundational stuff that would have to be in place. The satellite would have to be on board to the account and so on. If you're talking about post-processing or after the fact, then that's all defined by what you decide to architect in the publish column over here. Does that make sense?
Yeah, and I was thinking about it not necessarily in the schedule, but more of things that just kind of distance of how I wanted to explain. And that changes that architecture.
Not really. You can jump off from this point on the right here in many different directions. So with the same architecture.
Then I have one question. So when you talk about containerized, when you talk about the Lambda, if I understand that's like serverless.
That's correct. Yeah.
And then you have containers. Is there some kind of way that you make a choice between what you containerize and what you use Lambda for? Is there a specific approach there?
Yes, it's a little more than we can get into here, but I can talk about in the context of this what we're doing with Lambda. There's a few different Lambda functions in this stack actually, and one of those functions is when this contact completes and that event or that data arrives in that bucket after it's been processed to L0, then that event rule actually triggers a Lambda function that copies that image from one S3 bucket into another. And that's just a few lines of code. So that's a great use case for a Lambda function where you're triggering it based on either a cron job or an event, right? And then the container is we're running software provided by someone else, right? So that's what the container is doing. We're probably about out of time, right?
Yes.
Okay, thank you. I think there was one more
Go
question,
ahead,
but I
Dave.
can.
You might be cutting into the next speaker's.
Yeah, I'm okay with that.
Oh.
Thank you for your talk. As a CSPP developer, I'm wondering what was the biggest headache, or what is the biggest thing, the easiest thing that we could do to the software that would make this easier for you? Would it be S3 support for the lookup tables?
Yes. Yeah, and I would love to work with you more to understand, how we can architect better and how, maybe if there are things that you guys might want to think about implementing that would make this work better in a public cloud environment. Happy to help with that.
We'll see what kind of questions you guys have when I talk.
Sounds good. Thank you,
All right,
everyone.
thank you, Russ.
Yep.